And the first talk is by Tom Beadman. He works in the financial industry in the UK, in London, where else, I guess, if you work in finance in the UK. And he's going to give us an experience report about using MPS in that industry. You should thank him especially because yesterday was his birthday and he spent the birthday preparing the talk. So, Tom, thank you very much. And please go ahead.
Yeah, no, a pleasure to be here. Thank you. Thank you very much for having me. So yeah, thank you very much for that introduction. As Mark says, my name is Tom. I work for a company called Icon Solutions, and we kind of work in the financial space. And we adopted MPS 1 year ago as a kind of like one of part of our toolkit. And so this presentation is really kind of to go over what the DSL kind of does for us, and kind of what's happened over the past year, really. Okay, so let me get started. So kind of for today's talk, I'm just going to do a couple of minutes kind of on background and about the context, 10 minutes about kind of the overview of the DSL. So it's obviously a DSL that we use internally, so it's not publicly available, but we can talk through kind of some of the concepts and that sort of thing and have a look at it. And then the main section is really this kind of hands-on demo. So I'd like to kind of start from scratch with from a clean slate, but with a template project, build an application using MPS, and run it up inside a container and kind of see what's going on. And then finally, kind of 10 minutes to talk about kind of milestones and our observations over the past year of using MPS. And we are coming from it from the perspective of kind of, people who are very new to it. We're not language engineers. We're just kind of standard Java engineers who've picked this up and seen how powerful it is. So we kind of run into lots of the same challenges and overcome those kind of hurdles that I think a lot of people will as well. So that'd be quite useful. And then obviously these kind of 50 minutes towards the end for any kind of questions and answers. So with that, I think I'll get started. So just about a bit of background. So we're talking about kind of payments really at the moment. So if we think about making a payment, say if I want to pay Marcus and we're in different banks, what does that actually mean behind the scenes? So there are a kind of couple of key concepts that we can need to really define before we can identify where a DSL fits. So everyone knows what a bank is, so that's fine. It's a place that you hold an account, and then you kind of have different types of payments. So you know yourself that some payments can be quite instant. They can take a few seconds. Other payments may take several days. And so there's kind of different sorts of payments that can go to be processed. Now, in order for one bank to pay another bank, the payment needs to be kind of transferred over what's kind of known as a scheme. And this is kind of like a high level kind of specification really that defines the financial message exchange formats. And so you've kind of got operations in there such as, sending a payment, querying the status of a payment, cancelling one or returning one. But that's at kind of like a really kind of broad high level. So there'd be like European schemes. There's the concept of a clearing and settlement mechanism, which are sometimes called a CSM, and those typically implement a scheme. So they'll implement kind of the specification and provide that functionality to a certain geography over a central infrastructure. And so typically you have lots of these different CSMs which implement different schemes, and a bank will be able to pay other banks by going through these CSMs over these schemes and kind of building out that network. So the reach of a bank to be able to pay from bank A to bank B, which is in a different country, can be kind of seen as going through like a web of connections between CSMs to maybe other indirect banks and that sort of thing. So banks have an interest in obviously in building that kind of communication and connecting to these CSMs, and they may choose to kind of build everything in-house or buy off-the-shelf products in the form of payment service providers or a PSP. So a PSP may typically provide that kind of CSM connectivity as well as some kind of more orchestration-focused capabilities as well. So a bank may leverage those kind of PSPs to be able to connect out to a scheme. So those are a couple of some of the basic kind of concepts. And if we look about, okay, well, where does kind of MPS fit in here? So the company I work for, Icon Solutions, We are specialists in providing payment solutions and enterprise consulting for financial institutions. Of that point, we have a product called IPF, the Icon Payments Framework, and that is kind of like a platform or an open product that provides those kind of PSP capabilities, so scheme connectivity, payment orchestration, and that sort of thing. And its key focus really is orchestration of the payment processing, and also integration and integrating to bank systems. So MPS was kind of recently adopted as one of the approaches that we were going to use for our domain modeling, specifically for the orchestration aspect. And what we wanted to get out of that was kind of, extensibility, but also simplifying the engineering process. So that's kind of where MPS fits in the context of these things. So this diagram here is kind of a very, very crude view of if there's a person in the top left, they would like to pay someone from another bank. What that ultimately looks like is the bank connecting out to the scheme, either directly or through a PSP, in the form of a submit payment. But prior to that, there are lots of different things that the bank may or may not want to do with that payment. There are certain things that are always typically invoked, such as fraud, sanctions, and accounting. Those will be different systems for different banks, but the entire processing flow itself may also have a completely different shape. So there's kind of a kind of processing orchestration type flow prior to submission to the scheme, and that's where IPF currently fits. And then if we look at this from the beneficiary bank, so the other side, the bank who are receiving the payment, there's kind of like as you'd expect, a mirror image. So the originating bank who sent the payment through has gone via the scheme, is now being received by the beneficiary bank, and they may too require some kind of processing flow that they want to be able to build into that payment. And so when we kind of look at the different processing flows that can happen, we kind of see that it's a really good candidate for explicit modeling rather than just building in a traditional application. So the next question is kind of given that, well, why a DSL and why MPS? And why did we kind of choose to go with this? And so the IPF product has been around for a while. We're constantly innovating, and as part of our kind of previous innovation round, we kind of looked to a more extensible kind of software architecture. So adopting event-driven focuses, event sourcing, and kind of be more microservice orientated as well. And that provided us with a kind of a good platform or a good opportunity to also review our domain modeling approach. So we had a previous approach in terms of domain modeling, but it was using kind of an external tool. It was kind of one of those visual modeling tools where business analysts could define a processing flow, and we would then take that model and then generate code off the back of it. But that was from a separate application, and it was quite heavyweight. And the code generation was also kind of not really coupled to the internal model. You were always generating from a foreign model effectively. And so because of that, the code that was generated was quite anemic. It wasn't really that valuable. It was kind of boilerplate stuff, really. And also there was lots of bleeding between business and technical concerns because there was no real kind of concept of what the business flow was. There were technical concerns which were creeping in there. And the outcome from that is that the engineers who build software on top of the generated collateral from there are often fighting kind of against the grain because the intention has kind of been lost. So we needed a kind of an alternative to look to, a nice kind of lightweight alternative. And I guess some of the characteristics of the alternative that we were looking for, we wanted full control over the model. We wanted to be able to define kind of concepts that were meaningful to us, as well as the kind of process from the editing through to generating and that sort of thing. Because by having kind of more control of the entire process, we were going to end up with higher quality generated code. We also kind of wanted better integration with our existing developer tools and workflow. So we wanted that to be kind of smoother and potentially transparent as well. we kind of wanted that high quality generated code and for it to be self-contained as well. We didn't just want to create kind of anemic functions. We wanted to be able to build a kind of generate a domain which was a true representation of the model. And the desire for the model itself to be liberated from the application and decoupled from the runtime technology. So that's kind of what we were looking for, and MPS kind of really fit the bill on that from our kind of experience. So yeah, the next section really is to kind of look at the kind of concepts that we came up with and the concepts of the DSL. So before, I guess, kind of looking at the exact concepts, these are what we wanted the DSL to be able to generate for us, and what it currently does. So we're kind of going backwards a bit, but the first and kind of the most prominent is the ability to generate a self-contained Java domain. So what we're generating is an event-sourced Java domain powered by akka, by Lightbend, and it's modeled as an event-driven finite state machine. So, finite state machines should be kind of no stranger to DSLs. That's kind of where we're going. And that's achieved by a generator, a baseline generator. In addition to the main domain, we also want to generate lots of kind of auxiliary collateral, such as test-focused collateral. So in addition to generating kind of, Java classes that are suitable for testing, we're also generating BDD scripts. So we're a big proponent of behavior-driven development as an organization. And so by having the processing flow modeled in MPS, it allows us quite easily to be able to traverse it, the different processing paths, and define a BDD testing scenario for each one of the paths that could potentially happen during that processing flow. And then these BDD scripts are then further, leveraged by our testing harness further down the line. And then in addition to that, we generate documentation in the form of ASCII doc to help expose some of the concepts in the DSL, which feeds into a documentation pipeline, and also the visual collateral as well. So we knew that we were moving from a kind of visual model to code process to something which was more traditional by defining with a DSL, but we still wanted that kind of visual element as well. And so we generate graph representations as dot, and they get published as well. So that's kind of where we're aiming for and what we've ended up with, which I'll be able to show as part of the demo. Okay, so primary kind of language concepts. So these are just a kind of list of the most important kind of concepts that we built the DSL around. And this should be quite familiar to anyone who's kind of, built state machines and that sort of thing, or worked in kind of like a DDD process. But first of all, we define data. So we have data as a concept, and that has kind of IDs and also a link to the associated Java type, which allows us to, effectively generate kind of the correct Java types as part of generation. So we couldn't do without that, and that's where MPS proved really good, the interop with Java. We've got events, so those would be domain events that the business analyst would define as part of the DSL, but also kind of internal events as well. The scope of the DSL for a model is to be able to define a kind of a finite state machine which represents the processing for a domain or a single domain. Now, most non-trivial domains always need to interact with other domains really to get information, or to be able to kind of evoke kind of elsewhere, so that you can finally progress. You don't really kind of get lots of standalone things. So we have the concept of the external domain as a concept. And then we have the concepts of inputs and actions. So really these are instructions or commands being received into the domain, or responses, or instructions, commands, and requests being sent out. So those represent the inputs and the outputs to the domain itself. There's also the concept of kind of like a decision. So being able to perform a decision in multiple places as part of the state machine definition. And then finally, the behavior. And the behavior really is that kind of state machine representation. It's the domain itself, and it's built on top of all these other, and it uses all these other concepts. And as I said, there are kind of numerous other kind of supplementary concepts as well, but those are really the key ones. Now, if we have a look at kind of how those map through to the generated domain, it should not really be that kind of surprising that you define an event in the DSL, you get an event POJO generated off the back as well. But you also get all the other collateral which is needed. So the finite state machine takes the form of an ACCA event sourced behavior. The inputs come through to commands, and then depending on the domain and how things are configured, there are obviously command handlers, command processors, event handlers. There's the idea of kind of the aggregate, which is the summation of all of the data and all of the states. And we need to generate lots of other kind of common platform classes. And those inputs and those actions that represented the input and output, those get generated into input and action ports. So in I guess ports and adapters architecture, those are kind of like interfaces into the domain that the application can hook in, and interfaces out that the application will then support. So let's keep going. Generated domain. Right.
Tom,
So
before you do the demo,
Sure.
just briefly, I forgot to mention this before. If you guys have questions, please type them into the chat in YouTube, and I will collect them and ask them later. So far, we have no questions, so I thought I'd emphasize that's the way we should do it.
Okay.
All right, dropping out again.
No, that's great. Thank you. Cheers. Okay, so that's kind of the outlook. So let's have a look at the demo. But before jumping into that, just a couple of notes on what we're building as part of the demo. So I'm going to start from scratch, but rather than cloning a kind of example project and changing a bunch of stuff and then kind of testing it, we're going to leverage just a quick tool built with Omen. So this is going to allow me to kind of build a sample project with a example MPS solution using the language, but parameterized as we build it up. And it's generating really a multi-module Maven project where the MPS module is kind of one small component of that, and that's represented in the domain. And then what we build out from that is we're gonna generate the MPS solution. It's gonna build a domain which is built on top of ACCA. There's also a kind of really thin application layer, Spring Boot application, that effectively wraps the generated domain, and it exposes the commands out on a REST API, and then finally bundle that into a container and run it up, all as kind of part of the same process. So that's kind of where we're aiming. So let me move over to the terminal. Okay, so that should be showing okay. Friend, let me know if it's not clear. Right, so we've kind of got a blank directory. So now I'm going to invoke the generator, and then this is basically just going to ask me a couple of questions, and it's just going to name the project, set some kind of packages and that sort of thing, and add the templates. So let's do pasta. Why not? Let's just do base package conf food. Great. And then on there it said what model template should be used, and it said example fraud. So it's created us a bunch of files. If I have a look at what those actual files are, we can have a look at the MPS solution. So we can see that it's generated a top-level project, and it's got those kind of three modules which we looked at on the slide. So a domain module, an app module, and then a kind of container module. Within the domain root, one of those submodules is an MPS project, and it's built a solution called Pasta, but it's using the example fraud template, and it's got these there. So whilst I'm looking at this, I'm just going to set the build off to compile it. That takes a second. Bear with me 1 sec. New. So anyone kind of familiar with Maven, this is just doing a Maven clean install, skipping the tests, and it's also passing a parameter just to build a container. So instead of looking at the build script for Maven, let's just have a quick talk about what's going through on here. So when the build goes through, it first of all compiles the MPS module. And what that does is it goes away and it downloads a version of MPS from, I think it's the Itemis Maven repository, pulls it down, and it compiles the pasta solution using the build script against that version of MPS with all the kind of plugins configured and everything. And at that point, all of the generated collateral is kind of in the target directory of MPS. We've then got these kind of sibling modules, the docs and the domain and the test, and their Maven process is basically to go into the MPS directory that's been generated and to extract all the collateral that they care about. So the domain will get all of the domain classes, the docs will get all the documentation, and the test will get all the test classes. And at that point, none of the downstream project really kind of cares about the MPS module at that anymore. The application only really cares about the domain, and so it imports that as part of the build for the application. It builds a container, and at that point we can run it up. So I'm now just going to open up MPS and we can have a look at that solution. 1 second. Using the handy JetBrains toolbox. Okay, so whilst that's starting, I'm just going to start the containers as well. Okay, so let's have a look in here. There's the H. Was not showing it. 1 second. Oh, there we go. So we have our kind of pasta project. We've got the kind of 3 modules in there. As part of the domain, we have the MPS project. Let me open that up. Just ignore these warnings. Great. Okay, so it's kind of very, very simple. It's kind of just created the solution, which has been parameterized with the values we put in as part of the generator. And it contains some usages of the DSL. So first of all, let's have a look at the data library, what's called business data. So we can see here that we're kind of just defining different data points that are being used for this example. If I enable a technical view, we can all see that we've got the data type there. So this is kind of our how we handle kind of representing different types to generate to on the domain side. So we care about the sender name, the recipient name, and the amount. Obviously auto completing on there, that's picking up one of the Java types. Once we've defined the data, we then want to associate that with the domain. So this is how we define kind of the state machine. And we recently added, which I'll throw on here, the graphical view, which kind of gets launched by an intention. And so we kind of said that the graphical view really was something that we were generating off the back. But very recently we decided, well, we don't actually need to generate it. We can load it up as part of the editor as well. And so for those interested, you can know it's kind of like it's listening via, I guess you call it node listeners. If I change validating there, we can see all that. If anyone's kind of got any interest on this, give me a shout afterwards, because it goes through quite so many hoops to get this. But this is a flow that we're kind of modeling. So we receive a payment and it goes into a validating stage. Upon the validation response, we make a decision as to whether or not we need to check fraud. If we don't need to check fraud, we just go straight through to successfully processed. If we do need to check fraud, then we go to checking fraud, and then based on the fraud outcome, either it's rejected or successfully processed. So that's kind of the flow we're looking at. And you can see here that we've got the payment request received event, which is associated with those data elements. And so by doing that, you kind of build up what data is required. and ultimately that gets propagated through. So if we have a look at the decision for well, I'll tell you what, let's have a quick look. So the decision as to whether or not it requires a fraud check is the concept of decision that we've got here. I can get rid of that. So we've modeled a decision by leveraging the lightweight DSL, and this is a relatively new addition as well. Previously, we used to define application decisions, associate them with data that they operated on, and basically what that would just generate into an interface that the application would then need to implement. But then we thought, well, rather than leaving the application to do it, why can we not make the domain be a bit more autonomous and have those decisions there as well? But we didn't want to reinvent the wheel. So lightweight DSL proved to be quite useful to be able to define this function, which would then be used in the appropriate place. So that's like a look at the DSL. Now, let's just quickly, what I'd like to do is we can go in, test it, then come back, make a change in the DSL, redeploy, and see what happens. So let's have a look. So Docker Compose has started. If I go onto here, there should be localhost. So this is just a really simple web page that we put to save having to do curl requests to be able to trigger this processing flow. So let's say Tom sends Pat 50. Initiate the payment. And we can see that it got successfully processed and the previous state was validating, which is great. If I send Pat 150, we can see that it went to a successful process, but it also bypassed, it also went through the check-in fraud stage. And throw out, sorry, check-in fraud. On the fraud bit here, we have a magic value to say that if the recipient is max, then we should reject that as well. Sorry. Let's send 150, must be a bit suspicious. Then we go through and we can say, right, okay, so it was checking fraud and it was rejected at that point. So that's just proving that it's generated. If we now look at making a change, and what does that look like? Let's do that on here. So let's add a new business data point. Let's say that we add a new field. Let's call it false fraud. Let's make it a Boolean. So we're gonna have a flag that the initiating request can set, so that we always go to fraud regardless of the amount of the payment. So the payment was only going to go to fraud if it was greater than 100. So on here we can go in and say, right, this decision is also dependent on false fraud. We're going to say that, okay, we want this to return true if the amount is greater than 100, or false fraud. Now I can generate this in the IDE, and that'll be perfectly fine, but I want it to be absorbed into the application and redeploy. So it's quicker for me just to do the Maven install. Whilst that's building, so just to whilst that's building, just to recap what we've done. So, oh well, that's probably not. I've destroyed everything by doing a Maven clean install, so I won't go into MPS whilst it's doing that. But essentially, we've added a new data point. We've associated it with the event that is triggered by the initiation of the payment, which means that it's required on the command. And we're rebuilding everything, and the command is currently being exposed as a REST API. So I should be able to now go back into the application. Oh, what's happened on here? That does not look healthy. Okay. I think I kind of maybe messed something up. So in the interest of time, I might kind of skip over this point. Let me just try and regenerate it from here. Okay, let's leave that. A couple of teething issues, but that's fine. Okay, so let's kind of maybe move on to the, I guess, are there any kind of questions on the demo before kind of moving on to the next section, which is talking about the different milestones and what we've built?
So yes, indeed, there was one question.
Okay.
How do you keep templates in line with the MPS model? I don't know what
yeah,
templates they're referring to.
Yeah, it's an interesting question. We kind of need to find a proper, currently it's a manual process. So we would be up-versioning the template effectively, or up-versioning kind of an example, going through, seeing what the actual changes are, and kind of then backporting them into the template. I'm sure there's a kind of nicer way, but the templating aspect for us is kind of just a kind of quality of life thing. It's not a crucial point of the process, but yeah, currently we're, I guess, retrofitting the changes.
This templating refers to the stuff that's generated by Omen. That's the templates you refer to.
Yes. Yeah.
Okay. All right.
Yeah. Exactly. Yeah.
Okay.
Yeah.
Any other question at this point? Doesn't look like it. If I ask now, of course, it takes 10 seconds until it propagates down to YouTube. So I suggest you continue.
Yeah. No, that's great. That's current. Okay. So yeah, and we kind of obviously generate kind of other collateral such as the BDD scenarios and that sort of thing, which we find very useful as well. So the next section would be, I guess, just kind of talking about our experiences building this kind of over the past year. So there's been kind of a team or between kind of like 1 and 3 at times, kind of working on this on and off. So kind of broken it down into different quarters. So the kind of the main milestone that we kind of had during the first quarter was the initial proof of concept and kind of getting to grips with MPS and kind of seeing why it's valuable. And for me personally, it was the interoperability with the Java types from the language itself, but also when building a generator and that sort of thing, that seemed very, very like powerful. And the ability to kind of generate multiple outputs. I'm not sure if it's kind of like a purist way of putting it, but the fact that we're able to kind of generate documentation as well as test scenarios, as well as application code and that sort of thing from a single model was extremely powerful. And it's you're kind of in the best place to be able to do that within MPS, and kind of appreciating the projectional editor. So like even now, kind of a year on, I'm always kind of like running into issues or what I perceive as issues. I'm sure other people do as well. But it's once you understand what it's actually doing, it's kind of so powerful, and it often just kind of needs that extra bit of guidance from maybe someone else who's worked with it, or maybe like the Slack channel and things like that. But it is extremely powerful. And then the second point was, how do we get this as part of our kind of application, and kind of like building from the command line, really. So how do we use MPS as part of our toolkit for modeling our domain, but also kind of keep it simple and transparent to kind of downstream developers effectively. So the ability to download MPS, a headless version of MPS, and use it as part of the Maven build process was a key kind of hurdle that we got over, thanks to lots of other people's help. And then all of the things that are required to be able to do that, such as defining build solutions, being able to kind of do the plugin management and dependency management. So shout out to Federico for, I think it was one of his blog articles about how to sort out your kind of dependencies was really helpful on that and getting started. That's good. And then kind of looking to the kind of the second quarter, really, then we looked at, right, well, okay, fine. How do we start using the language in our downstream projects? Obviously, this is kind of like private and internal, so it's not publicly available. So we have to build the plugin as currently as a zip, And then we publish that to our internal nexus, and therefore it can be used and imported with Maven as kind of any other kind of build artifact. And then we started looking at, well, what does the downstream project need to look like in order to be able to build it this way? And so we kind of looked at this, because if you imagine this, there's so much kind of complexity. If there's so much kind of complexity in terms of setting up that build structure to be able to have it transparent and effective, and what was the best way of doing that? And we kind of looked at we leveraged Maven's kind of concept of the differences between a parent POM, parent module, and an aggregator POM. And so a project in Maven, a POM, can have a parent, and therefore the child will inherit not only kind of the dependencies as you would expect, but also all the plugin configuration. And so we were able to kind of encapsulate all of that heavyweight MPS processing build configuration in a parent POM, and therefore the downstream project just needs to have a kind of POM which inherits from there, and it doesn't need to have any content effectively. I think it needs to specify what the solution name may be. But it's by leveraging those starter modules there. And those starter modules live in the repository of the language itself. So if you change the language or kind of the process at the kind of language level, you can change the starter modules, and then all the other projects downstream, they just need to up version their parent version effectively. So taking a new version of the language becomes kind of synonymous almost with upgrading a Maven property version, which is very powerful. And then we kind of go further with that and say, well, okay, how do we guarantee that the downstream project structure is going to be consistent? And that's kind of where we look into kind of like Yeoman and templating and that sort of thing as well. But there are also different approaches. Off the back of that, we then introduced the kind of integration test module. So this was going to be an example downstream project structure module that was part of the main language lifecycle, and its job was to consume the language distribution zip, import it into its solution, and for it to build. And so it was really testing that the language had successfully built a coherent distribution zip. And so that was very, very important as well. So we couldn't release a version of the language if it was going to effectively break downstream projects, which is never desirable. We then kind of, obviously we're getting feedback through this entire process, but we had a kind of key feedback point in Q2 where we're able to present this DSL not only to kind of like our internal developers, but also to clients who would be kind of using our software and were interested about what our engineering process was. And the kind of the feedback is generally extremely positive, and especially if you kind of get those kind of clients who are technical as well, and especially if they've been exposed to previous DSLs, they immediately get it, and that was really great. But they did raise kind of interesting questions for us to kind of consider about what we wanted our DSL to do regarding extensibility and kind of reusability of language, like the DSL components, which we'll have a look at in a second. During kind of Q3, we kind of stress tested the DSL by modeling different use cases. So, you can imagine a single microservice with multiple different domains working together. What should that separation be? Should it be represented at the language level or the application level? And that sort of thing. And off the back of trying these different use cases, we got lots of new language enhancements, language requests to be more generic, and we kind of also refined kind of the scope of the language and what it should be. And then we also had at that point kind of support from JetBrains as well. So thanks to Vaclav and Artem, who worked with us to kind of go through a checklist about things that we were doing maybe correctly, things that we could improve on, and that sort of thing. And it probably surprises no one. A lot of kind of the improvements that we could make were based around kind of our generator. It was a bit monolithic. With their help, we managed to kind of split it down and make it more modular and more kind of reusable and all that sort of stuff. At this point, again, we kind of then looked at, well, how do we handle the reusability? So the question was from the client is, well, so if I can define my domain in your DSL and I can define my external domains in your DSL, how can I reuse those external domains in a different domain that you're also building for me effectively? And so we kind of pondered that, and the initial view was to look into kind of cross-model generation, and to effectively kind of allow partial DSLs to be made and then to be reused in existing models and that sort of thing. The more we kind of explored it, we kind of put a lot of time into it, we kind of realized that for our use case, it was becoming like overly complex. So one of the Icon Solutions kind of tenets really is to kind of simplify complexity when you see it. So we kind of took a step back and was like, there's something that tells us this probably isn't the correct way of going about solving the problem. So we kind of instead kind of took it back and thought that we can provide reusability at kind of the application level, but as far as the DSL, that's kind of self-contained within the domain. It's okay to have kind of redundancy and repetition between domains. And so from that, we kind of thought, well, we'll continue just with like the templating approach, but also looking into kind of the new persisting your model on a DB kind of features. I think there's a talk coming up about, but we kind of think that might be our preferred option to go with. And then kind of finally, I think this is almost like the last slide before questions really, it's the kind of the most recent improvements that we've done. So we did some kind of technical quality of life improvements. So we were running into issues where we had a duplicate kind of mapping label, multiple reference macros being identified for a certain mapping, and kind of duplication. And if we imagine that we've got the idea of a data point, and we know that we've kind of got the idea of an aggregate, which is going to have a list of all the data points which are used as part of the domain. But we also know that the inputs and the commands, they supply those data points. But different commands may supply kind of the same data point effectively. So in terms of generating through onto the aggregate, you can't just take all of the data in the DSL because it may not be used. But there's no direct link from the state machine to all of the data points it uses. You need to go to each of the commands it receives and get the data from there. So there's a degree of separation. And because of that degree of separation, there's also the issue of duplication. So we really needed to be generating from a relationship that existed, but didn't exist in the DSL. And the relationship was that, this state machine uses these unique data points. And so we built that, and we leveraged the kind of the preprocessor generation step to be able to programmatically build that kind of separate concept, like a contextual read-only kind of concept. And the generator can then leverage that to be able to map from those nodes, as opposed to trying to map from something else. So that was quite an important thing for us. Also leveraging the lightweight DSL constructs, kind of seen that. And also the Omen project instantiation, which is kind of like an extra bonus that we've got on there. So that was kind of on the technical side. On the user side as well, we did a rich client distribution option. So thanks, Pat. My colleagues made that, so that was great. So that allows kind of, it's a self-contained IDE, slightly kind of customized with our language. And so business analysts can use that to be able to kind of sketch up different flows. And then developers may just elect to use normal MPS with the DSL in the scope of a wider ecosystem. And then we got to the point of the kind of graph visualization. So previously we were generating this. We were generating using text gen through to dot, and then converting that to an SVG as part of the Maven step. But now we've kind of front loaded all of that into an intention within the editor. So I think, and someone's going to correct me probably, is that class as an interpreter? I'm not quite sure, but we'll find out. And then finally, kind of obviously better type checking rules and constraints. So kind of the general stuff needed to be able to ensure that the domain is kind of consistent. So that's it for my slides. So before I guess I'd say thanks to Marcus and JetBrains and Oscar for hosting and everything. I'm sure if there's any questions, that'd be great. But if not, you can follow me on Twitter, although I don't really post that much. And obviously, we're hiring. So if any of this looks interesting to anyone from language engineering or Java engineering or payments, why not? Feel free to get in touch. Thanks.
All right, Tom, thank you very much. I found it very interesting. We have a couple of, well, first I have a comment. I thought one thing your talk very nicely illustrated is that in addition to building a useful and usable language, this whole infrastructure around it, the automation through Yeoman and the build, is really important. You called it quality of life for users. I thought that was a nice term. And it's something that some people, including myself, tend to not emphasize so much. And it's that just build a cool language. I thought you put it into context very nicely.
Thanks.
Yeah. Any comments there, or should we continue with the questions?
No. I think yeah, that's true. There's I'm kind of personally always looking for building things which developers are going to enjoy, and obviously business people as well. But it's always that extra kind of I guess shine, or the extra kind of user interface that makes things slightly nicer to work with. MPS is extremely powerful, but there's a high barrier to entry to be able to adopt it without that kind of supporting process. And getting there, sometimes it is painful, but there's experts and there's the Slack channel, and there's lots of people willing to help. So thank you for helping us get there.
Yeah. Philip is asking in that same context, he's wondering why that Omen Generator was built in the first place. Do you create new model projects so frequently?
Potentially, yeah. So a lot of our projects are longer lived and they will kind of start from scratch. But there's been times, even this year, where I've needed to we're doing a proof of concept for a client, and I need maybe 5 or 6 different microservices, each with a slightly different kind of domain. And we need to be able to kind of prototype and build that out. So the Omen Generator is just a kind of an extra tool that we have at our disposal to be able to start something kind of up from scratch quickly, and to get that kind of that place there. But no, production projects, they're a bit longer lived, but we have to adapt.
Yeah, so you built it mostly to improve your own life.
I built it because I thought I started using JHipster and thought, wow, this is amazing. So out of interest, I kind of looked into how that was built, and then how we could template it with MPS as well, and thought that this is quite cool. So I kind of kept it maintained, but yeah, it's I could call it, what is it, like if you're buying a car, is it an optional extra or something like that? It's one of the comforts.
Right. So Julian asks, what tools, languages, IDEs were you using before MPS has replaced those? What was the previous tool set?
Sure. Yeah, sure. So MPS hasn't really replaced it, but the previous tool we were using was a Modelio. So I'm not sure if kind of people are aware of it, but it's kind of like an enterprise model to enterprise diagram to kind of model solution. And off the back of that, it ends up with a kind of XMI format. And our generation was translating that XMI with Python into Java code, which worked. But it worked when we had a kind of narrow focus that our product was going to be specifically focused on instant payments. And now we're kind of changing to be able to support different payment types. We needed a more flexible architecture. So once we moved to be kind of event driven, that was a good opportunity to say, right, can we just use a DSL here rather than have this dependency on such a big external product?
Yeah, I was going to ask, you used the word heavyweight and lightweight, and I was wondering what that heavyweight solution was, but now you mentioned a tool whose name starts with enterprise, and that explains it, right? So usually these are heavyweight. Paul says, yesterday Marcus implied that making a graphical projection was more effort than value. You used the visualization instead, one that updates real time, which is actually quite nice, my comment. What was your experience with that? Is that a good compromise?
Yeah, I think so. So yeah, so that's kind of, so we always knew that we were going to need a graphical representation in order to be able to get anybody on board with using this DSL kind of really, because as nice as kind of the state machine is, it's very difficult to be able to kind of see exactly kind of what's going on. So we always knew that we're going to need to translate to graphs. And that's just kind of done using, JGraphT or something like that. The process of then front loading from the generation through into the intention in MPS was quite interesting, but very, very much doable. It's basically injecting kind of the swing components into the editor and that sort of thing. What I found is a lot of these sample projects that come with MPS contain exactly what you need to know to be able to solve these problems. So in order to be able to have that diagram that pops up, that's in the shapes example. In order to be able to use lightweight DSL, it's in the lightweight DSL example and that sort of thing. So if there are kind of a message for anyone wanting to get started, aside from everything else everyone else has said, it would be to consult those.
Yeah, that's one of the nice things, because everything is kind of defined in MPS. You can always do a Control-Shift-S and inspect everything, and so it's not necessarily always easy to understand conceptually, but technically everything is explorable, which is nice. Yeah. How big is the audience using the solution, and how technically advanced are these people so they don't struggle with the complexity of a desktop IDE? And I think Mike was asking that.
So that's a good question. So this is still kind of relatively recently adopted. So our IPF product, it's live with production kind of customers over the past 5 years, and this is a new addition. So we have a live project. We have a project which is currently being built, which is using it. We don't have anyone yet who's currently using this in a kind of live system, but we kind of work with our business analysts together with them, kind of using the solution, and we're currently going on that journey to see, okay, how do we make things better for the end user and that sort of thing. But we're learning. We're not language engineers yet, but I think it's kind of, hopefully it's good progress for you.
One experience many of us had is that it's relatively feasible and maybe even easy to build a language that is accessible to non-programmers, to domain experts, if the language fits well with the domain. But if you then give them this huge tool with 5 million buttons and Git integration, and it just overwhelms people. And one way to simplify that is to deploy, and as we call it, RCP, term developed from the Eclipse world. You remove all the menus and buttons that you really don't need. But this simplification and integration into people's workflow is a major driver for both Themis's and JetBrains' efforts of bringing all of this to the web. And we'll have talks about that later this week. But that's kind of where this comes from, right? To make the Chrome around it simpler, not just the language itself.
Definitely, and that's definitely one of the things we're going to be we're very eager to kind of look at, and I think a lot of people are as well. Is kind of the web side of it, and also as kind of mentioned that database persistence of models and that sort of thing, where we can have kind of repositories. Very, very, very interesting for us.
Yeah, Nolly is asking that MPS UI with sections. What was that, using the default MPS editor or with the help of Embedder?
I'm not sure what they're referring to, but this is pure
Me
MPS.
neither.
I can say that.
Okay, it's pure MPS. All right.
Yeah, it's pure MPS. So we haven't kind of used any of the special embedder add-ons or anything like that. So table editor, MPS, I think that's pretty much it. Okay.
So that's a question from me. You explained that you're generating BDD style tests, or at least test skeletons.
Yes.
Which means that you have to generate a lot of stuff, deploy all of it, run Docker, and then you, I guess, write BDD tests against the full system. Have you ever thought about also allowing your modelers, while they're in the IDE, to write tests against the model and not only against the fully generated and deployed solution afterwards? And if so, would that also be BDD, or would that be a kind of testing language that you would develop as well?
I think that's a good question. It's a shame that that last compile didn't go through. Let me just check if that was on there. But the BDD it currently generates, it will inspect the model and it will write a BDD scenario saying that, one, that results in the kind of fraud rejection, and two, that result in the success for the different permutations going through. But really that's just from the model side. And you know, you could say that, well, you're generating the domain from a model, you're generating the test case from the model. Is this not kind of a cyclical? What's the value of the test? Which is a fair argument, but the counter really is that the main purposes of those BDDs is to be able to illustrate the different scenarios through the processing path, so that when you build an application around the domain, you have a reference point to be able to kind of say, okay, does my application cover these scenarios and that sort of thing. So that's right. It's complementary to normal testing.
Exactly. So another way I like to say this is these kinds of generated tests, their purpose is to exercise the whole system and go through every kind of corner.
Yes.
It doesn't mean that every, let's say, business-driven corner case is covered, right? It's just complementary, just exactly as you say. Yeah.
Yeah, you can only test what's in the model and what's being modeled effectively.
Yeah.
So yeah, it's completely complementary, which is.
But I still think it would be nice if people could write tests against the state machine without all the generation backend stuff, just like more test-driven development of that thing. Could be an interesting avenue to explore in the future.
Yeah, definitely. Yeah, I think we're definitely kind of looking more into kind of the testing side, from testing the generated collateral, but then also node tests on the individual kind of, you know, parts of the language and editor tests. We're kind of building that knowledge and capability up as we're going through.
Right. All right. I have no more questions. Let's wait 10 seconds until this statement pops through to YouTube, and maybe somebody adds a last question there. Now I guess we have 8 seconds, 9, 10. No more questions. Then Tom, thank you very much. I thought it was a very interesting presentation. Thank you very much.
No, pleasure. Thanks for having me. And yeah, thanks for everyone's attention. Cool. Have a good session.